me start this up over here. Hello, come on, there we go. Hi everybody, I'm Scott Stanchfield, and today we're going to talk about factory method, abstract factory, and builders. So creational patterns, things that help you create different types of objects rather than just saying new. So first of all, new is evil. What does new dog do? It's not a trick question. Yeah, creates a new instance of dog. Okay, now why might that be bad? You have to create objects, right? But why might it be bad to say new dog in your code? Well, you're creating some tight coupling. Anytime you say new some class, you're coupling your class directly to another class. So that means if the other class, something changes about him, that's interesting, the phone's ringing. So if the other class, the dog in this case, changes, like let's say his constructor changes, then we have a code hit. If we want to create a different instance of a different type, we're locked into dog here, right? We can't just arbitrarily pick it. The idea here is to think about what you want versus what you want to do. New dog is saying what I want is a dog, right? You care about the thing itself. If I care, what I really care about when I'm talking to a dog is how I can communicate it and what I want it to do for me. So if we can abstract that out, that reduces our coupling. Rather than caring specifically about I depend on dog, I can say I depend on something that does something for me. Now the other thing that's a big problem with this is if we ever want to change it, let's say instead of creating a new dog, we want to create a new cat. We've got to go to every spot where it says new dog and make a change to that. And sometimes you might miss. I mean, if you happen to have all your code loaded up in your IDE, you can do a search for it really well. But if you don't have something checked out that uses it, that might not work. So you might miss something, and that can create a big problem there. Now, let's say, for example, that we wanted to decorate or adapt this, and we're going to talk about those patterns next month. If we want to tweak the behavior of the dog or change something to make it look like a dog, we have to go and actually change the new for every place there. If we wanted to create an instance of a subclass, like let's say instead of a dog, we had a fluffy dog. Let's say it's a subclass, something like that. We'd have to, again, go to every place and change it. So it kind of locks us down. What we really want to try to do is create loose coupling in our applications. Now, coupling is really a continuum. It's not a kind of absolute, this is loose and this is tight coupling. There's different types of coupling, but I like to think of mainly three categories. First of all, if you have no coupling, so you don't depend on anything else, that's the cleanest you can get, right? Because if anything else changes, it doesn't affect you. The problem is you're going to lose function, because usually you need to depend on other things to do some things for you. But if you can do everything for yourself, hey, that's kind of ideal. On the other end, you have class-to-class coupling, which is where you say, I depend on this specific guy here. If anything about him changes, or if he goes away, or if you want a different thing, it's fragile. You have to make some changes there. Now, if we can instead, whoops, that's we already talked about that. If we can instead think about coupling to an interface, or an abstract class, depending on the language you're using, then what we're doing here is setting it up so that we care about what something can do for us. And that makes us really, really flexible, because we can plug in different things in place of that interface. It's a really nice thing. Again, we're thinking about what do I need to do as opposed to what do I want. So what it can do for me, the contract versus who it is. You also think about what do I need others to do for me. Again, contract type information. We want to try to get to a point where we don't care who they are, we just care what they can do for us. So let's think about how calling new can become a little bit of a problem. So right here, if we created an interface, we say void bark is a barker. We're going to create a class dog who implements a barker, and then down here we can say barker barker equals new dog. Now what we've done, instead of saying dog dog equals new dog, is at least on the variable side here, we've abstracted it, right? We still have this called a new dog, which is the problem. So if we take a look in these two things, when we say barker.bark, what do we care about here? We're just caring that the dog can bark for us, right? We're not caring that it's a dog. It could be a dire wolf. It could be anything else. So what we're going to do is take that new expression and replace it with a method call. And what that does for us is we have a barker, or a method here called create barker, which returns a barker. And now we've put that call to new dog in one place. That reduces our surface area. So if we ever want to be able to, if we ever want to be able to create something different, we just have to go to one place and change it. And that's a pretty big benefit for us there. And every place we use it, we just say barker equals create barker. So logically, when we look at this right here, there's no coupling in this line at this spot. We've reduced our coupling to one spot. The fewer places you have coupling, the less fragile you are. And the easier you are to adapt, the less chance that you can miss something. So let's take a look at some examples. I'm going to first of all take a look at sample 1 up here, and I'm going to leave the slide available so people can take a look at it in case they want to see descriptions of this. But let's look at the code. It's a little more descriptive. So we're going to start off. Here's my barker interface. Very simple. We've already seen that guy. And we define a dog that barks. He just says woof. Now I'm also defining a dire wolf that is a barker. I'm just going to make him woof louder. So we have 2 concrete implementations of that barker guy there. Now if we start with sample 1 here, let's take a look at some different ways we can create instances of these guys. So foo1a and foo1b actually create things directly and then call them. So we'll see dog, dog, and dire wolf, dire wolf. So we have some pretty tight coupling here. In this case here, we're creating that new dog and making him bark. We know it's a dog. We're creating a dire wolf and make him bark. We know he's a dire wolf. So these 2 methods here are about as tightly coupled to something on the outside as we can possibly get. Now we can make it a little bit more flexible by changing the variable declaration. That reduces our surface area as far as our dependency on the external guy. We still have these new dogs over here. Whoops, this one should say new dire wolf. Okay, so we still have our dependencies on the outer guy here, but we'll notice now that the code that follows it doesn't depend on that class. So we're reducing our coupling just a little bit there. Now we can get a little bit better by creating this factory method. So now if we look at foo3, there is 0 coupling to outside classes at this point. The only coupling we have is to barker. So we say barker is create barker, and then barker.bark. So foo3, all he cares about now is barker. He no longer cares about a dog or a dire wolf. Now if we imagine every place in our application that needs a barker called like this, those all stay very, very independent. And then create barker here, if we ever want to change it, we have a single place to change it here. So if we take a look at sample 2, we'll see what I've done here is I've changed, I still have foo3 is exactly the same code, but I've changed create barker to return a dire wolf. So I can change it in one spot, and that's a huge benefit right up front there. Makes us a little bit more flexible. So now let's think about what we can do and be able to reuse code a little bit more. Hello. So what we're going to do now is use inheritance to help us replace part, but not have to repeat the code in that foo3 method. So we saw in this example here, I had the exact same foo3 in both of these classes, just so I could change what the factory method was. So instead of doing that, what I'm going to do is take advantage of inheritance. So if we start with sample 3 here, and the only change that I've made is to make this guy protected, so I can override it instead of making him private. Foo, which is the same as that foo3 method, stays exactly the same. And then in sample 4, I extend sample 3 and override my create barker. So I've simplified things a little bit. I've avoided repeating myself in the code. This is one way you can change what is actually going to be created. Just create a subclass. So if I called foo from sample 4, I'm going to get a dire wolf. If I call foo from sample 3, I'm going to get a normal dog. Make sense? Let's get a little smarter about it. What if we could take that factory method out of the class? So instead of having it be in sample 3 or sample 4, if we had it someplace else, it becomes a strategy. We can plug it in and then allow anybody to plug in different implementations. That makes us really, really useful. So what I'm going to do, let's switch to a different version of the repository. I'm going to start off by defining a Barker creator. So this is an interface that describes that factory method. Instead of having just a method hard-coded somewhere, we're now creating an abstraction of it to say, here's what it means to create a Barker. And then we're going to create 2 subclasses of that. Direwolf creator, which creates a Barker, and dog creator. Dog creator creates a dog, direwolf creator creates a direwolf. So now we've abstracted out those 2 factory methods so they're on their own. And what that does for us now is in sample 5, we can make it completely independent of the actual objects we're creating. So sample 5 lets us pass in a Barker creator, which is going to be creating our objects for us, by calling set Barker creator. And we just have a getter there just in case somebody gets interested in it. So now my foo is just going to say, hey, Barker creator, create a Barker for me. And now this code has no coupling on external classes. It's only coupled via interfaces. That's very flexible for us now. And if we take a look at our app now allows us to use that exact same sample 5 instance to work with dogs or work with direwolves, depending on what we pass in. So if we pass in a dog creator or a direwolf creator, we're going to get different results from these. So when I run this, we get a lower wolf for the dog and an upper wolf for the direwolf. Okay, make sense? Now these pass in things here, we could use some kind of tool that does dependency injection. We could use like Spring or something like that and configure it at runtime or configure it at deploy time to say, what do we want to create, dogs or direwolves? And that makes us much more flexible. So now let's think about a really practical example instead of talking about dogs and direwolves here. Let's say that we have a binary tree. And this binary tree implementation, it's going to be the same binary tree implementation I did with template method and strategy a while back. But I'm going to take this binary tree, and what we want to try to do is change the behavior of what happens when you walk that binary tree. We're going to use a traditional template method, but we're going to see that there's a problem with this and how it ends up working. So let's start off by looking at binary tree node 1. This is a very simple binary tree implementation. He has a left node and a right node and a piece of data that's going to be an integer. I'm going to allow us to get the data in case anybody's interested in what's inside of it. We have a constructor that creates being passed in that piece of data. And then we have 2 recursive methods here, insert and in order. Insert is going to check to see should the data be on our left or right, based on is it less than our current data. If it's on our left and we don't have a left, we just create a new node for our left. Otherwise, we're going to say, hey, delegate it down to that left branch. Let that left subtree handle the insertion. And so we recurse there by calling left.insert. Otherwise, we do the same type of thing on the right. If we don't have a right, we create a new node for it. Otherwise, we delegate to it. So this is a nice little recursive insert. Our in-order traversal, again, another recursive method. The idea is handle the stuff in my left subtree, handle me, whoops, and then handle the stuff in my right subtree. Now, I'm using this as a template method. So we have the basic structure in both places here, and then the hook method, the what to do, is a strategy that's just implemented as a method. So in this in-order traversal, we're going to walk through it and print out the data for each node. Nice and simple. So let's look at what that looks like here. So we'll go with app 1. So our first app here, we're going to create a root node with 42 as our value. And I'm just going to call a bunch of inserts to just put some data inside there. Once we're done with that, we're going to run our in-order traversal. So let's say run as Java application, and boom. We see that our nodes are all printed in order. Nice and simple. Now, one of the advantages of template method using it this way is that we can override those hook methods. So I'm going to do that in binary tree node 1a. I'm going to extend binary tree node. I need the constructor just so I can pass through the data. But I'm going to override handle this node. So what I'd like to try to do here is when I'm printing my tree, put a suffix of exclamation marks after it. What do you think is going to happen when I run this? If I use this to create my root node, do all my inserts, and then run it. Okay, so the goal is that we should see the same results with exclamation marks after everything, right? Let's see what happens. What happened there? We're only seeing exclamation marks once. Can somebody grab the door? Thank you. Why on earth are we only seeing exclamation marks in the one spot? When we have our binary tree node 1, the insert method is defined in binary tree node 1, right? Binary tree node 1 explicitly says, the problem here is that in binary tree node 1, he's the guy who defines insert, right? And when he's defining insert, he's explicitly creating instances of binary tree node 1. So when he is displaying his data, if the instance is an instance of binary tree node 1a, his handle this node will print the exclamation marks. That's the subclass. If his instance is just of a binary tree node 1, his instance will just print the data without the exclamation marks. So we look at app 1a. App 1a creates a binary tree node 1a for the root. But every time we call insert, that's defined on the superclass, which explicitly creates the binary tree node 1. So that's where our problem is. So what we need to do is we need to set this up so that the factory method is something we can override as well. So we'll switch over to him. And if we take a look now at binary tree node 2, binary tree node 2 is exactly the same, but I added in a create node method. And the create node is going to return a binary tree node 2, passing in his data. And what we're going to do is in our insert is instead of creating an explicit node type, we just say create node, which now we can override. So now our insert becomes another template method with a hook. And then we define in our binary tree node 2, we override create node. So that anytime we have a binary tree node 2, if we're going to create children for him, we create binary tree node, 2a. Anytime we have a 2a, anytime we create children for him, we create a binary tree node 2a as well. Does that make sense? So now when we take a look at app 2a and run him, we see exclamation marks on everybody. Whoops. And he is exactly the same type. Let's see. So the app, if we look at the app 2a, his code is exactly the same as that other one, with the exception of we're just creating a 2a instead of a 2. Make sense? So that's one of the advantages of having that factory method is now we can have our subclasses create instances that they need to repeat their process. If you have a recursive data structure, for example. Okay, so let's think about taking these factory methods and just move them out. So instead of having them inside a class, let's put them somewhere else so everybody can use them. So anytime somebody wants to create a dog, they can ask this factory using a static method to create a dog. And the nice thing about a static class is that you don't need to have anything passed in as your factory, and you don't need to own the factory. So we'll check him out. And we're going to start off by taking a look at a simple data model here. And our little data model is just going to be defining types of cars. So we have a convertible interface, a coupe interface, and a sedan interface. And then we have Toyota and Ford cars underneath here. So we have a Camry, which is a sedan, Corolla, which is a coupe, MR2, which is a convertible. And then we have a probe. You can notice this example is pretty old, right? We have a probe, which is a coupe. We have a Taurus, which is a sedan, and a Mustang, which is a convertible. So those are all our possible pieces of data there. And then we're going to take a look at how we can create these. So I'm going to create a factory. This is a very, very simple factory. This guy just says, if I'm asked for a sedan, return a Camry. If I'm asked for a convertible, return an MR2. If I'm asked for a coupe, return a Corolla. So this factory represents Toyota here. And then in my application, I can just say, hey, factory create a sedan, factory create a coupe, factory create a convertible, and use those. So it's really nice and straightforward. And if we run it, we get what we expected, the Camry, the MR2, and the Corolla. So that's kind of a really raw, basic way of looking at it. And the nice thing about this is now I can go to that factory class and change what I want to actually have created for my entire application, as opposed to just for one class. Let's take a look at number 2 here. This time, I'm going to abstract things out just a little bit. I created a properties file here that says sedan, I want a Taurus, coupe, I want a probe, convertible, I want a Mustang. And now in my factory, I'm going to say, first of all, read that properties file, load it into this properties object, which is just basically a hash map. And then when I'm asked to create a sedan, if the properties sedan said Camry, return a new Camry, otherwise return a new Taurus. So now I'm giving it some flexibility based on configuration. So if I changed my factory properties, instead of saying Taurus there, if I said Camry instead of for the sedan, then it'll create a Camry, but still create a probe and a Mustang. So now it's externally configurable by data, which is nice. So if we run this guy, we'll see that I have my Taurus, my Mustang, and my probe. If I change this piece of data to be Camry, and then run it, we have Camry, Mustang, and probe. Make sense? Okay, so just by tweaking this piece of data, we change what's actually created in the application. So this has actually reduced our coupling a little bit more, right? Now we don't care, the code doesn't say explicitly what we create. We're now parameterized, but the code still has the possibilities in here, right? Hard-coded. So what we can do instead of that is make things even more flexible. Let's just go ahead and put the full names of those classes in our factory.properties. So now the actual instances are completely factored out. And if we look at our factory even becomes simpler now. So we have we have the read our properties file. And then whenever we're asked to create an instance of something, I'm going to use reflection to do that. I'm going to say class.forename, look up the actual class, and then create a new instance of it. So notice in here, there's nothing in here that says Camry, Taurus, Probe, Corolla, MR2, or Mustang, right? That's all completely abstracted out. And now down here, when we're asked to create a sedan, convertible, or coupe, we just say, go get sedan, convertible, or coupe, and then create the instances. So there's zero external dependency here on the actual concrete classes that we're creating. So if we take a look at this guy and run him, here again, the code stays the same, factory create sedan, factory create convertible. We can say run as Java application, and poof, we get the Taurus, Mustang, and the probe. If I go into my properties and change this to Camry, and now run it, I'm actually creating the instance of the Camry this time. So this gives me a lot of flexibility and a lot of decoupling. Questions so far? Okay, so swap back over here. So we did our multiple variations. Here's the different variations we just walked through. The first one, factory explicitly creates the instance. Second, the factory explicitly creates instances based on names. The third one, the factory creates instances based on class names in the property file. Okay, so that last one is a lot more ideal here. So some pros and cons here. By using this external factory, we've moved the coupling out to minimal place. So across the entire application now, we have one place referencing Camry or Taurus or whatever. or the abstraction of pulling it out of the properties file name. Another one here is that our properties file allows changes to behavior without changing code. So if we use that properties file, it's data driven now. We can configure it and deploy different properties files to get different effects. We can mix and match things. We saw how I had in that one properties file, I kept switching between Camry and Taurus, which I can, if I decide my car dealership is going to sell a Toyota sedan, but everything else is Ford, I can do that, right? But that's a con too, right? What if my intent is really that I'm always selling Fords or I'm always selling Toyotas? I never mix and match. In this particular example, using the properties file, I can accidentally mix and match. And I may not want to do that. This also allows us to not be able to, this doesn't allow us to change values for different purposes, for different uses. Let's say that in the morning, we want to create Fords, and in the afternoon, we want to create Toyotas. We can't do that in this example because our factory basically is an all or nothing. Everybody says, I'm going to use this external factory, and it can only create one type of thing. If your goal is that anytime anybody asks for a sedan, they always get the same thing, this is a good approach. But if you want more flexibility and say sometimes I might want to create Toyotas, sometimes I want to create Fords, we got to go with a different solution. So what we're going to do is create something called an abstract factory. What we want to do is, first of all, create our factory and make the factory just dirt simple. Let's go ahead and hard code in Camry, Corolla, and MR2 in one factory instance. And in a separate factory instance, we're going to hard code in Taurus, Probe, and Mustang. The code stays nice and simple. We don't have to worry about configuration. But then what we do is our configuration just chooses which of those two factories to use. And then that way we can say, I want to use the Toyota factory, or I want to use the Ford factory. And that makes our life a little bit simpler code-wise and configuration-wise. And you can't mix and match. You can't get an accidental mix and match. Your properties file just says which factory to use. And the factory defines a set of methods for creating each of those guys, and they're all related. So if you always want to keep your methods related, using an abstract factory lets you define, whenever I get this factory, I'm always getting these three definitions. You don't get any accidental mixes and matches. So what we're going to look here is we're going to take the guts of that factory class. We're still going to use that external factory kind of as a shell. But we're going to have him load up an abstract factory under the covers and delegate to it. Now, you don't have to do it this way, but I just wanted to have a stepwise of taking the last example and just kind of gut it a little bit. So what we're going to look at here is in my factory properties, I'm just going to have one property. And he says which factory I care to use. I'm defining car factory as an interface here to describe the abstract factory. Now, it could be an abstract class as well. Either way, depends on which language you're using. But in this case, the idea of a car factory is I can create a sedan, I can create a vertical, create a coupe. Then I have a Ford factory, which is nice and simple. He just explicitly returns Taurus, Mustang, and Probe. And then I have a Toyota factory. He's pretty simple. I return a Camry, MR2, and a Corolla. So those stay nice and simple. I don't have to worry about configuration and accidentally getting configuration wrong on those guys. Then what I'm doing is I'm going to replace the guts of my factory. So I'm still going to read my properties file like I did before. But what I'm going to do is I'm going to create an instance of the factory instead of creating an instance of each individual car on the fly. So create instance stays exactly the same, I'm just doing reflection. But I'm going to look in that factory properties and get the property for car factory. Create an instance of that car factory and hold on to it. And then anytime somebody asks me to create a sedan, convertible, or a coupe, I'm just going to delegate to it. So I'm just kind of hiding that under the covers. So this is kind of a nice stepwise version. Note that any code calling this didn't have to change now, right? I've just swapped out the guts. Everybody else was already calling this factory class. Now I'm just swapping out what happens under the covers. So if I look at the app on this guy, this app, I'm going to say factory create sedan, factory create convertible, factory create coupe. And if I run it, it's the exact same code as before. boom, I get my Camry, MR2, and Corolla. If I switch to my factory properties to say, instead of Toyota factory, I say Ford factory, and then rerun it, I get my Ford stuff instead. So now it's a little bit simpler for configuration as well. Okay, so let's simplify that just a little bit. Let's say that we didn't have the existing framework we needed to stick in with that external factory. Let's think about, let's explicitly create that instance of which factory we want and pass it where we need to. So we're basically doing dependency injection at this point. So this makes your life a lot easier for unit testing. Instead of having this external class that has static methods that you call, which is that's a real pain for unit testing, we're going to have a separate instance. So let's look in here and check him out. And notice that I have very little code in here now anymore. I just have my car factory, same as before. My Ford factory, same as before. My Toyota factory, same as before. But my app is changing. Instead of calling factory.these static methods, now what I'm going to do is I'm just going to explicitly pass in which car factory I want to use whenever I want to use it. So if I had some object that was going to create cars, I would pass it in maybe to a constructor, or maybe call a setter. In this case, I'm running just a couple little tests here. And so what I'm going to do is I'm going to say, I want to test using a Toyota factory. I want to test using a Ford factory. The code here is almost the same as that previous example. But the difference is, instead of saying factory with an uppercase F and calling static methods here, I'm just talking to this instance that was passed in. So now this code in here, again, he's not coupled to anybody hardwired. Everything he's talking to is interfaces. That makes him very flexible. Somewhere I need to configure which instances I'm using. I could have read these using the property file and create an instance based on that. That would have worked as well. But I could also just create hard-coded stuff. It now gives me a choice, which makes it easier to unit test and makes it fairly easy to configure overall as well. Make sense? Okay, so if I run this guy, I'm going to see two groups of things run. First of all, I get my Toyota stuff running, and then I got my Ford stuff running. Okay, makes sense. So there's a bunch of different variations you can use on factories. Starting with just a simple factory method that will let you kind of gather up all the places that something's created into one spot, so it's easy to change, easy to manage. You could override that in subclasses. You could pass it in as a strategy. Or you could move these guys into external factories that do a whole bunch of creations, potentially all related, in which case you want to use an abstract factory, or maybe you configure it via a property file. So you have several choices. Now the other creational pattern we're going to talk about today is the builder pattern. And the idea of the builder pattern is that we're going to assemble some kind of object or a graph of objects and then return it. And that assembly might be fairly complex under the covers. To handle this complex creation, I'm going to break it into a couple parts, a director and builders. Each builder here is essentially an expert. He knows how to build certain types of things. And you can swap out different ways of building for that. The director is responsible for saying what order those builders get called in and which parts of the builders are used. Let's take a look at a concrete example of this. I had a home built back in the late 90s, and I was a future homeowner. I went down and talked to a general contractor who knew how to build a certain type of house. I picked out from a little brochure which style of house I wanted built, and each style of house might have a separate general contractor responsible for building that. Maybe the house has certain extra types of rooms, maybe there's different types of building materials, maybe there's a different order things need to be built in. That general contractor, when he goes to build the house, doesn't actually do the building himself. He delegates that to people who are experts in doing certain parts of the building. So he might get a bricklayer involved to actually create the frame of the house. He might get a plumber involved to actually put the plumbing in, and an electrician to do all the wiring in the house. Then, of course, you're going to have other things for the people who are going to be doing the windows, people who are going to do the insulation, people who are going to do air conditioning, things like that. So he's responsible for delegating all the work to the experts. And we could pop in different experts, right? We might have different bricklayers involved. Maybe if I went to Shady Home Building Company, I get a bricklayer who has no idea what he's doing and puts the bricks together without any mortar. He's still doing his job, just not doing it well. If I go to a more reputable one, they're going to get someone who knows how to lay bricks, puts them in place. We could use the exact same general contractor in both cases, because all he's doing is saying, hey, bricklayer, put a wall there, put a wall there, put a wall there. And the bricklayer says, okay, I'll create a wall here, create a wall here, create a wall here. And the way he creates the walls depends on his skill level. But as far as the general contractor is concerned, there's a wall in one spot, another wall in another spot, another wall in another spot. Contractor will then say, hey, plumber, put pipes here, 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 and here. Different plumbers might have different quality of work, but as far as the general contractor is concerned, he can still talk to them the same way. Make sense? Now, anybody ever played Diablo 2, Diablo 3? Yep, hand goes up really fast. The maps in Diablo 2 and Diablo 3 are dynamically generated. So you don't see the same map every time. So if we think about the way the map is laid out, there might be a couple main layout algorithms. One that lays things out with a very traditional labyrinth type structure. Another one that lays things out as kind of like fields with little caves and things. Another one that might lay things out as a jungle. That might represent our director, the structure, where to put the walls, where to put the treasures, where to put the monsters. And then you might be able to use the same algorithm for different environments. So you might have an environment that looks all lush and green. You might have another one that looks like a castle. You might have one that looks like a spooky cave. Those environments might represent your builder, so that we can apply a maze algorithm on different builders. How do I draw a wall? Well, I draw a wall looking like a spooky cave versus a nice, pristine castle wall type thing. Different type of monsters. The maze says, put a monster of level 1 here, put a monster of level 2 here, put a monster of level 3 here. Well, different environments might have different types of monsters. So we put that in there. Now, I don't know if they're using a builder pattern for it, but that's a perfect example of when a builder pattern is useful. Because now, instead of having to have for every possible combination, maybe I create one class that says nice walls, labyrinth maze, another one that says scary walls, labyrinth maze. Instead of having all those combinations, we separate the work out into the maze structure and the way things look in the maze. Make sense? Now let's take a look at a quick example. Okay, why does it want me to stash if there's nothing to stash? Let's see if we can fix that real quick. Let's go ahead and commit those. Okay. That's better. So now we have our builder up here. So let's look at the traditional gang of 4 builder pattern to start with here. I'm going to define a pizza. A pizza is just going to be a holder for items. So I'm just going to have it keep track of a list, and you can add things to it. And then when you print it, it's just going to list those items that are on there just so we can see them. Now, I'm going to define a bunch of builders and directors here. So let's first of all look at the builders. I'm going to have a core builder. This is the thing that's going to let us roll the dough, spread the sauce, and add the cheese on the pizza. And then I'm going to have a couple implementations of that. I have a basic core builder, which is just going to say I have basic dough, tomato sauce, and mozzarella cheese. And then I'm going to have a fancy core builder, which says artisan dough, artisan sauce, and artisan cheese. Whatever artisan means. I have no idea. I mean, what is an artisan? It's somebody who knows how to put something together. Whatever. And then we're going to have a meat builder. Add pepperoni, add sausage, and add chicken. And we have a basic meat builder, which has pepperoni, sausage, and chicken. And we have a fancy meat builder, which has snobby pepperoni, snobby sausage, and snobby chicken. And then we're going to have a veggie builder. Add mushrooms, add peppers, and add nasty stuff. I'm not big on vegetables. And what we're going to do for him is we have our basic veggie builder, mushrooms, peppers, and nasty, nasty, nasty stuff. And then our fancy veggie builder, fungus du jour, precisely colored peppers, and colorful, nasty, nasty, nasty stuff. So those are our examples for what our builders are going to do for us. Now for our director, we're going to define a pizza director. And he just has one method, make pizza. So somebody can say, hey, pizza director, make pizza. And we're going to use the pizza director to build our specialty pizzas. So like our meat lovers pizza, our veggie pizza, our everything pizza. Think of those as the builder, as the director. He's orchestrating what to put on the pizza. So maybe if you think about this in a pizza joint, you have one person assigned to each of those tasks. One person knows how to make an everything pizza. One person knows how to make a veggie pizza. One person knows how to make a meat pizza. And then maybe somebody else does custom pizzas. But custom pizzas wouldn't use this pattern. So our everything director, we're going to pass in the three builders. So we can use the same director for fancy or basic. We're going to pass in those builders. And then when he's making a pizza, he's just going to go through the process of roll the dough, add the cheese, spread the sauce, add the chicken, add pepperoni, add sausage, add mushrooms, add peppers, and add nasty stuff. And then return the pizza. So he's basically added everything on there. Our meat director is a little simpler. He doesn't need a veggie builder because he doesn't believe in vegetables. And he's going to say roll the dough, add the cheese, spread the sauce, add the chicken, add pepperoni, and add sausage. And then our veggie director doesn't need a meat builder because he doesn't have meat on the pizza. He's going to roll the dough, add the cheese, spread the sauce, add the mushrooms, add the peppers, and add nasty stuff. So we have our two layers, the what kind of pizza to make, and then how to put the individual ingredients on. So now if we look at our app, we can put things together. And I just created a little helper method here called Go that takes in a pizza director, tells the director to make the pizza, and then just prints the pizza. And so I'm going to configure up here what our pizza builders look like. So I'm going to have somebody make an everything pizza using basic ingredients here. I'm going to have somebody make a veggie pizza using basic ingredients. I'm going to have somebody make a different veggie pizza using fancy ingredients. And you can mix and match the ingredient sets as much as you want here. And so if we run this guy, boom, the first one we get the basic dough, mozzarella, tomato, and then based on if they're doing a veggie or an everything, you can see everything got put on there. The last one there was the veggie director with the artisan stuff being passed in. So this allows you to do that nice mix and match. And one of the things that's kind of nice about this pattern is you don't have to think about this up front. If you take all of your creation and move it into a factory to start with, and then replace the guts of the factory with calls to the builder, you now have that flexibility to mix and match things, as you wish at runtime. So you can kind of factor your way into it. Now, this is the Gang of Four factory pattern. So if you pick up the Gamma Helm, Felicities, and Johnson design patterns book, this is what you'll see described there. Now they describe it just slightly different. They actually have you ask the contractor to create something, and then at some later date, you reach around him to the experts and say, give me your finished product. Which that can work out well if you have an asynchronous builder type situation. So like in the case of me building a house, I had to wait quite a while for the finished product. It's not like I say, general contractor, build me a house, and I stand there and wait for him. At some later date, he's going to come back to me, or the experts are going to say, here's your house. So that's one way of doing it. Now, there's another pattern out there that people call a builder, which is unfortunate because they're overloading the term, but it's a different kind of builder. This other builder, not the same as a golf builder, is really just a Fluent API for creating objects. What we're going to do is we're going to create an object that they call a builder. Don't get it confused with the Gang of Four builder. And you load that builder up with your values. So if I'm creating a dog, I might say, hey, builder, the name is Fido, the age is 2, and the type is Corgi. And then once you've filled everything up, you say build. to create it. And there might be a complex build process behind this. Now, the example I'm going to show you, it's not really a complex build process. All I'm going to do before the build is make sure that all three of these have been specified. But this lets you build something up and then create it. So let's take a look at that example. So I'm going to start by looking at the dog class here. So dog defines an enum for the type, corgi, pug, whatever else. Defines some data he's going to hold on to, name, age, and type. And he has a constructor to create him. Getters and setters for all those guys, basic Pojo here. And a toString to just dump it. Then I'm going to define this builder. And typically when you use this pattern, you define an inner class called builder. You don't have to. You could put it someplace else. But quite often you'll see people say it's a subclass that you can reference from outside. So we're going to create an instance of it. I don't have a constructor in here because there's no values, no arguments to constructor. I'm going to have three methods, name, age, and type, that take in the parameters you want to do, set them, and then return this so you can chain these guys. So this allows you to say .name, .age, .type because it keeps returning that same builder over and over again. And it's kind of a nice way to create a nice fluent API on this thing. Sometimes you'll see people in a class itself, instead of having the setters return void, the setters will actually return this instance as well. And then that would allow you to say set name, set age, set something. So you could say new dog, set name, set age, set whatever. And that allows you to chain it together, which can be kind of nice. Okay, but this builder pattern typically has another object involved. When it comes time to build it, which is the last call in the chain, note that it's returning a dog, not a builder. The build is just going to check, in this case, I'm just checking to see, did you specify everything? Did you miss one of those calls? Okay. Maybe it'd be useful to have something that's mutually exclusive. Maybe you can specify an age or a type, but not both. That's when this build method might actually be very useful because then you can get a little more validation between properties. Are the values consistent with each other? Maybe for some reason, corgis can never be older than 3 years old. I don't know. The corgi, the walking ottoman, it's this crazy looking little dog. So I'm just going to do some validation, and then I'm going to actually create my object. Now you might also have a much more complex object graph you're creating under the covers here. Maybe you set a bunch of properties and it looks like there's just at one level, but maybe, let's say that there was a property here that said owner or caregiver, depending on if you live in Berkeley. In that case, if I said owner with a name, maybe under the covers it actually has to create a person object and then attach that person object as the person, as the owner, and then also have a name in the person object. So it'd be a little bit more complex. But it gives you a capability to build things up a little bit nicer. So my app can now look like this. Create the builder, set these values, and then build. Poof. Nice and simple. So when I run this guy, boom, I get my dog created. And just let me really quickly show you that person example here. So if I created a class called person, and then I have a private string, oh, nice fingers. So we create our getters and setters on there. Maybe we'll put a constructor in there as well. And then in my dog, let's add in here an owner method. Owner, string owner. Oops. So we have the owner, and then when we're building this, and then I can say person owner. I'll just say person. I didn't add that in there, did I? Create some getters and setters. Note in this case, the owner isn't getting passed into the constructor, so I need to do something a little more complex. Do something like that, and then return the dog. And then we'll rebuild our toString. So it includes the person. We'll add a toString in the person. Kind of like that. And now let's see what happens if I add in here. Well, first of all, let's run it without actually adding in the person there. And it's going to give us that exception because we didn't specify our owner. So now I'll put in the owner here. And we can run it again. And now we see that the owner person name equals Scott got in there. So we can use this builder to kind of flatten out the creation or simplify the creation and then create all these other objects for us. So it gives a nice fluent API way. I think it's a little bit more readable in many ways to create instances. But you'll notice in this case, we basically had twice the data because we have to create it in the builder and then actually create the instance of it. So maybe that's not a great thing. It could be, might not, hard to tell. You could also have, as a slight change in this, maybe what we do, let me get rid of this constructor. Is we do this. We actually create the dog up front and then explicitly set his fields as we go. So now each of these guys becomes a little bit simpler. So we'll say dog.name equals that, dog.age, dog.type, dog.owner equals new person owner. And I'll pretend that we did that validation. And then we just do that. So maybe now what we do is we reduce the amount of data we're keeping track of and just have this hold on to a dog and gradually build him up for us. The results will be the same when I run it. Everything works out just fine. But now we've reduced our data requirements. And we still have this fluent API. Make sense? Okay, any questions on anything? Well, thank you for coming. I'm going to go ahead and post these online. The place that I post them is at javadude.com/articles/patterns. I'll also be posting an announcement about where these things are located so that you can take a look later on if you're interested. And hope to see you next month. Is create loose coupling in our applications. Now, coupling is really a continuum. It's not a kind of absolute, this is loose and this is tight coupling. There's different types of coupling, but I like to think of mainly three categories. First of all, if you have no coupling, so you don't depend on anything else, that's the cleanest you can get, right? Because if anything else changes, it doesn't affect you. The problem is you're going to lose function because usually you need to depend on other things to do some things for you. But if you can do everything for yourself, hey, that's kind of ideal. On the other end, you have class-to-class coupling, which is where you say, I depend on this specific guy here. If anything about him changes, or if he goes away, or if you want a different thing, it's fragile. You have to make some changes there. Now, if we can instead, whoops, that's we already talked about that. If we can instead think about coupling to an interface or an abstract class, depending on the language you're using, then what we're doing here is setting it up so that we care about what something can do for us. And that makes us really, really flexible because we can plug in different things in place of that interface. It's a really nice thing. Again, we're thinking about what do I need to do as opposed to what do I want. So what it can do for me, the contract versus who it is. You also think about what do I need others. Let me start this up over here. Hello, come on, there we go. Hi everybody, I'm Scott Stanchfield, and today we're going to talk about factory method, abstract factory, and builders. So creational patterns, things that help you create different types of objects rather than just saying new. So first of all, new is evil. What does new dog do? It's not a trick question. Yeah, creates a new instance of dog. Okay, now why might that be bad? You have to create objects, right? But why might it be bad to say new dog in your code? Well, you're creating some tight coupling. Anytime you say new some class, you're coupling your class directly to another class. So that means if the other class, something changes about him, that's interesting, the phone's ringing. So if the other class, the dog in this case, changes, like let's say his constructor changes, then we have a code hit. If we want to create a different instance of a different type, we're locked into dog here, right? We can't just arbitrarily pick it. The idea here is to think about what you want versus what you want to do. New dog is saying what I want is a dog, right? You care about the thing itself. If I care, what I really care about when I'm talking to a dog is how I can communicate it and what I want it to do for me. So if we can abstract that out, that reduces our coupling. Rather than caring specifically about I depend on dog, I can say I depend on something that does something for me. Now, the other thing that's a big problem with this is if we ever want to change it, let's say instead of creating a new dog, we want to create a new cat. We've got to go to every spot where it says new dog and make a change to that. And sometimes you might miss. I mean, if you happen to have all your code loaded up in your IDE, you can do a search for it really well. But if you don't have something checked out that uses it, that might not work. So you might miss something, and that can create a big problem there. Now, let's say, for example, that we wanted to decorate or adapt this, and we're going to talk about those patterns next month. If we want to tweak the behavior of the dog or change something to make it look like a dog, we have to go and actually change the new for every place there. If we wanted to create an instance of a subclass, like let's say instead of a dog, we had a fluffy dog. Let's say it's a subclass, something like that. We'd have to, again, go to every place and change it. So it kind of locks us down. What we really want to try to do is to do for me, again, contract type information. We want to try to get to a point where we don't care who they are, we just care what they can do for us. So let's think about how calling new can become a little bit of a problem. So right here, if we created an interface, we say void bark is a barker. We're going to create a class dog who implements a barker. And then down here we can say barker equals new dog. Now what we've done instead of saying dog equals new dog is at least on the variable side here, we've abstracted it, right? We still have this called a new dog, which is the problem. So if we take a look in these two things, when we say barker.bark, what do we care about here? We're just caring that the dog can bark for us, right? We're not caring that it's a dog. It could be a direwolf. It could be anything else. So what we're going to do is take that new expression and replace it with a method call. And what that does for us is we have a barker, or a method here called create barker, which returns a barker. And now we've put that call to new dog in one place. That reduces our surface area. So if we ever want to be able to, if we ever want to be able to create something different, we just have to go to one place and change it. And that's a pretty big benefit for us there. And every place we use it, we just say barker equals create barker. So logically, when we look at this right here, there's no coupling in this line at this spot. We've reduced our coupling to one spot. The fewer places you have coupling, the less fragile you are. And the easier you are to adapt, the less chance that you can miss something. So let's take a look at some examples. I'm going to first of all take a look at sample 1 up here, and I'm going to leave the slide available so people can take a look at it in case they want to see descriptions of this. But let's look at the code. It's a little more descriptive. So we're going to start off. Here's my barker interface. Very simple. We've already seen that guy. And we define a dog that barks. He just says woof. Now I'm also defining a dire wolf that is a barker. I'm just going to make him woof louder. So we have two concrete implementations of that barker guy there. Now if we start with sample 1 here, let's take a look at some different ways we can create instances of these guys. So foo1a and foo1b actually create things directly and then call them. So we'll see dog and dire wolf. So we have some pretty tight coupling here. In this case here, we're creating that new dog and making him bark. We know it's a dog. We're creating a dire wolf and make him bark. We know he's a dire wolf.